Hello everybody, welcome back to our discussion in dynamics. Today's topic is projectile motion. And we're just going to focus today on projectile motion, yes? So last time I think we introduced Cartesian coordinate system. Yep, and today we will just use it to solve projectile motion. And we will show how to do it using two examples. Example number 1 and example number 2. Sounds like a plan for today? Okay, so let's dive straight into our discussion. As usually, please read and understand the problem statement before we start our solution. All right, so what do we have in here? We have our projectile that is initially at point A. Yep, our projectile is here. And I think that we know its velocity, yes? Its velocity has this direction, and it has initial speed of 250 feet per second. Moreover, we know these two angles, alpha and theta. Okay, so let's maybe write it down. Nonce. V0 is 250. We also know these two angles. Oh, this is 10. And we also know gravity. Yes, we move in a gravitational field. Gravity points downwards. And since we are using US units, yes, G will be 32.2 feet per second square. And they just ask us to find this distance, yes, distance D. Okay, any questions about the problem statement? So maybe let's start with two things before our solution. First of all, please observe that I am going to place our Cartesian coordinate system here. Okay, so this will be our datum. Yeah, this is our X. And this will be our Y. Yeah, they were already in the picture, but I just decided to make them larger. Okay, so please observe that. And maybe before we start solving the solution, before we start solving the problem, let's maybe find this distance. I would like to find this distance. Let's call it H, okay? Okay, so I believe that this angle is theta, right? So if that angle is theta, that angle has also be theta. So based on this green triangle, I hope that you guys can all see that our tan theta is H divided by D. And from here we have H. So H will be equal to D tan theta, or 10 degrees. Okay, with these two information we can start. Let me get rid of this green triangle. We don't need it. And this is how I solve these problems. Solution. So I'm just going to express the motion in the X and Y directions separately, yes? So let's focus first on the X direction. In the X direction. So what is the acceleration in the x direction?
0.
It is 0, exactly. If it's 0, we probably don't have to put units, but let's put them, okay? It will be 0 feet per second square. And it's actually, what's more important for us is that it is constant. Yes, it does not change over time. So our acceleration is constant. So it's ax, actually. I forgot about the subscript. So we could integrate it, yes, exactly how we did in the past. However, for the case where acceleration is constant, we have ready-to-go expressions, yes? Yeah, you can integrate and obtain exactly that. However, we are going to provide you these expressions on the page with the equations during your examples, okay? So Vx is equal to V0x plus AXT, okay? So just one more time, just to clarify. Only if acceleration is constant, this is true, okay? Only if acceleration is constant, yes? You can use this ready-to-go expression. If acceleration is not constant, you must integrate exactly how we did on Friday, exactly how we did last Wednesday, okay? Is that clear? Yeah. Can I tell you why I'm saying that? Because for some reason, usually you guys go for these expressions in the exams, okay? Even if acceleration is not constant, yes? So just keep that in mind. Please don't do that little typo, okay? Okay, sorry for that longer speech. Let's use that ready-to-go expression and simplify it. So you guys told me that ax is 0. So I can set it to 0. And what is v0x? Aha, in order to get it, I think I should project this vector on this direction and this direction, right? So this will be our v0x, and this will be our v0y. Okay, so v0x will be v0 sine or cosine? Cosine. And it was u? Yes. So you have a homework to do, okay? Trigonometry, okay? This is cosine alpha. And the other one has no other choice, okay? v0 sine alpha. Okay. So our Vx of t will be v0 cosine alpha, which is constant. This is also a constant expression, which should not be surprising for us, yes, because acceleration was 0. Yeah, so if acceleration is 0, velocity will be constant. We would not accelerate or decelerate. Okay, so what is ready-to-go expression for position? It's following. X of t is x0 plus v0x t plus 1/2 ax t squared. For the 7th time today, this is true only if acceleration is constant. Okay, this expression for position is only when acceleration is constant. If it is not constant, it will look different. And you have to, I don't know how it will look like actually. Okay, let's fill out our ready-to-go expression. This is 0. And what is x0? What is our position? Initial? Why? Exactly, perfect, yes. Based on the picture. Yeah, based on the picture, it is 0. You can see, guys, that our projectile is aligned with that black dot, yes? So it is, yeah, our projectile starts at origin. It is 0 based on the picture. Based on the peak. Okay. So we obtained that our x of t is a linear function of time, yes? It will be v0 cosine alpha t, which makes sense, yeah? Acceleration was 0, so our position should be a linear function of time. Okay, I am done with what happens in the x direction. Any questions? We good? Yeah. Okay, so let's see what happens in the y direction. Yeah. Even if you don't have a question right now, you can ask it later. No worries. You can ask question at any time you want. In the y direction. So what is acceleration y? Ay. Anybody? Negative gravity, perfect. And again, it is constant. So if it's constant, we can use ready-to-go expression for velocity. Vy of t is equal to v0y plus ay t. Let's fill it out. So our Vy of t will be V0 sine alpha minus gt, right? Okay, so now our velocity is linear function of time, yes? Because our acceleration was constant and not zero. Now position. Let's use again ready-to-go expression. Y0 plus V0 yt plus half ayt squared. Okay, and y0 is 0 for the same reason as before. So y of t is equal to v0 sine alpha t minus 1/2 gt squared. Awesome. Look what happened, guys. We have expressions for velocity in x and y directions, and also we have expressions for position in x and y directions. Yeah, so basically we have equations of motion. Yes, we exactly know how our particle moves. Yeah, these are expressions, by the way, for this trajectory. You can see this parabola here. So this is our trajectory right now. And these expressions exactly describe that parabola. What do they ask us for? They asked us to find d. Yes? So I think I would like to give you the mic. Once you have these 4 expressions in the black boxes, what's the strategy? How would you find d? Yeah. Sean, you want to do it? Okay. And what this will give you? Exactly. Let's do that. He's right. Yeah. So what Sean said that we should use these 2 expressions, this and that. Yeah, because at point B, at this point, so I don't know, how would you like to call the time we are at point B, like time final? TF, let's do it. Yeah. So at TF, at T final, our projectile is at B. Yeah. So that means that x of TF will be equal to d, and y of TF will be equal to what? What is that? Yeah, somebody said it? Negative h. Yes, it will be negative h. However, we have expression for h with respect to d. Yes, so h will be d tan of theta, right? Okay, so let's use this information. So we will have d that is equal to v0 cosine alpha t final, and negative d tan theta is equal to v0 sine alpha t final minus 1/2 g t final. Cool. I think we ended up with two equations and two unknowns, I believe. Because our unknowns are d and t final. So this is solvable. This is solvable. Okay, so let's find TF, exactly what Sean said. TF can be expressed as d divided by v0 cosine alpha. And now let's plug this expression in this equation. And we will end up with something following. Minus d tan theta, and this is equal to v0 sine alpha times d v0 cosine alpha minus 1/2 g d squared v0 squared cosine squared alpha. Okay, I think we are getting closer to the solution. So I think that we can simplify that expression, yes, because these can be simplified, yes, and I also believe that this v0 can be simplified with this v0, and that's all we can do in here. So we will have minus tan theta is equal to tan alpha minus 1/2 g v0 squared cosine squared alpha times d. Okay, and they ask us for d, so let's solve it. So d will be equal to tan theta plus tan alpha times 2v0 squared cosine squared alpha divided by g. I think I didn't make any mistake, yeah? Anyway, you can double check my calculations. Let's plug in values. I believe that theta was 10 degrees. Alpha was 15 degrees. But I don't remember v0. Was it 250? I believe so. Can I scroll up the board? Yeah, dang, it was 250. Check this out. Okay, let's plug it in. So it will be 2 times 250 squared cosine squared 15 degrees. And g, since we operate in US units, this will be 32.2. Grab your calculators if you want and obtain that this is approximately 1609.143 feet. Okay, any questions? So this is our distance. Yes, sir?
There's really no significance to whether we choose like to solve an x, like x coordinates is reversed or like we can find like the equation motion in x direction, equation motion in y direction.
Yes, of course. They are independent from each other. Yes. Okay, guys. Any other question? Yeah, if you really would like to, you can find time final also. Yes, if you want to do like 101. Thank you. Yeah. Just for those of you who were late, please put your name on the list after the discussion. Okay, so we can also do time final. Yeah, if you look in the top right corner, we can say that T final will be approximately 1609,143. V0 was 250, now I remember, and alpha was 15 degrees, cosine 15 degrees. Grab your calculators and obtain that T final is approximately 6.664 seconds. Yeah, they didn't ask us for it, but we did it. Okay. Okay, how are you doing, guys? How does it look like from your perspective? Is it okay? So what, example number 2? Yeah. Would you like to have such problem on the quiz? Maybe, yes. Everybody? Okay. Okay, we will see. Example number 2. As usually, please read and understand the problem statement before we start our solution. Okay, so what do we have in here? We have our projectile again, our firework that we will model as a projectile, and it starts from here. Yes, and I think that we already see that that problem will be exactly the same as the previous one. The only difference is that we have no incline. Yes, I believe so. Yeah, we will see. Anyway, again, we know the initial velocity, so let's write it here. Nonce v0 is 300 meters per second. Oh, and we operate in SI units, yes? So no more US units, but this time SI units. And we also know that H max, yes, H max is 500 meters. And G this time will be not 32.2, but this time it will be 9.81 meters per second square. Okay, and that H max defines the peak of that parabola, yes? H max tells us how high that parabola is. And by the way, this is our trajectory right now. Yes, this is our trajectory. It's a parabola. Okay, what they ask us to find? In part A, actually, they ask us to find theta max such that H max is exactly as above. And then in part B, so once we are done with part A, they told us that then find corresponding distance, yes? Corresponding D. Okay, guys. Any questions about the problem statement? So the solution steps will be exactly the same. I'm going to solve it in exactly the same way, okay? So I probably can even stop talking for like 5 minutes, yes? And just put down exactly the same equations as before. So let's do it. But I will not stop talking, okay? I will put our coordinate system here. So this is our X. This is our Y. You can see that our particle again starts from origin. solution in the x direction. Or if you want, you can start from the y direction, if you would like to. But again, ax is 0, and it's constant. So our Vx will look like that. This is 0. Okay, Vx we need. So I need to project these two vectors again. The dead vector on these two directions. This is V0x. This is V0y. So V0x will be V0 sine or cosine? Yes, cosine theta. And the other one has no other choice. Yes, it will be V0 sine theta. Okay. Our position in the x direction can be expressed in the following way. But only if acceleration is constant. And this is 0. And this is 0. We start from origin, yes? All right. So let me fill out that quickly. Okay, we are done with expressions for x. I think I didn't make any mistake, yes? So let me do it also quickly for y, and then you will tell me what is the strategy, okay? You can start thinking about it right now even, yes? So I'm just gonna create equations of motion in the y direction, but you guys can start thinking how to find theta max, okay, using these expressions. If you want to, of course. So again, acceleration in the y will be minus g, it's constant. Ayt. Okay, so Vy will have this form, V0 sine theta minus gt. That's great. And now position. Yeah, as you can see, there's like a recipe to solve that problem. Yes, I can follow these steps, and I can solve any problem of that kind. This is 0. So we'll end up with V0 sine theta t minus 1/2 gt squared. Okay. It took us some time, but we ended up with 4 equations of motion. Again, yes? They are in these black boxes. Okay, guys, so anybody want to help me? Once we have these equations, what is the strategy to find theta max? And what this will give me?
No, because there's no.
Yeah. But it will work, but maybe as a second step. Yeah. Yes, sir?
Rather than also plug not.
No or
Yeah, I think we not into the velocity equation and set that equal to
what?
Does that be set to 0 since at the top it'll be oh yeah.
Yeah, that's true. Yeah, okay. This is what you want to say? This is what you want. Yeah, yeah. And this is what you wanted to say as well. Yes. Yeah, so basically, so you're Jaden. What's your name?
Joey.
Joey. And what's your name, sir?
Charlie.
Charlie, Joey, Jaden. And you, sir?
Prashant.
Kushan. Yes. Okay, I will learn it. Yeah, sorry. Okay, so what these guys observed is that at the top, at this point, yeah, first of all, our velocity is horizontal, yes? V of y is 0. Yep. And plus, also, Jaden said that our position in the y direction is 500. Yes. So we are just this time. So before we use these two equations, this and that. Yep. Right now, we are just going to use this one and this one. Okay. And by the way, these two requirements will be obtained at some time instant. Yeah. How would you like to call that time? Like time star or time top? Yeah. T max or T. No. Yeah. T top. I prefer T top. Yeah. Let's say. Okay. So at T top or T max is good. Yeah. T top. So when T equals to T top, we for sure have y of T top that is equal to 500, and also Vy at T top does not exist, yes? It's 0 meters per second. Okay, so, and we will solve that problem using that. Awesome, guys, thank you. So, what do we have in here? So we have 0 that is equal to this expression, yes? 0 will be equal to V0 sine theta minus gt top. Yeah, and from this we know that our t top will be equal to V0 divided by g sine theta. Awesome. Okay, and now since we have t top, we can use this. We can write down 500 that is equal to V0 sine theta V0 g sine theta minus 1/2 g V0 squared g squared sine squared theta. Yeah. It's almost correct expression. I would accept that actually, but remember that at 500 we should have theta max. Yes. So 500 corresponds to theta max. So we also have to put here everywhere theta max. I mean max in that subscript. Max, max, max. Yes. Because 500 is obtained for that angle. Yes. Not for any other. Yep. Okay. Can we simplify that expression somehow? Yes, we can. I think that this g simplifies with this one. Oh, and there will be like some V0 squares, yes? So I can write 500 that is equal to V0 square divided by g sine squared theta max, right? Minus 1/2 of V0 square divided by g sine squared theta max. And I can simplify it further. Do you see, guys, that in here we have something minus 1/2 of exactly the same thing? Yep. So we have something minus 1/2 of exactly the same thing that done before. Yeah, so this will be equal actually to 500 of half v0 squared g sine theta max squared. Okay, let's find theta max because this is what they ask us for, yes? So our sine of theta max squared will be equal to 1000 v0, no, 1000 g divided by v0 squared. And from here, we see that theta max will be arc sine um, 1000 here, g in here, square root here, v0. Okay, let's plug in values. G was 9.81 and v0 was 300 in this case. I'm sorry, my memory is not working well recently. Yeah, but I don't believe you. Yes, that's true. That's true. 300. Yes. Okay. Grab your calculators and obtain that theta max is approximately 19.278.
300 squared on the bottom, right?
19.278. I don't think so. Yeah. If I take the square root of all, the entire fraction, yeah. Then yes. Okay, guys. We are done with part A, I believe, yes? So again, how does it look like from your perspective? Digestible? Is it okay? Yeah. So let's look at that problem, like, you know, from a different angle. Like, I mean, let's look like an overview. I think that the physics stops here. Yeah. So if you write down these two equations, physics almost stops. Yes. Then you just have to find these two requirements. Yes. And then the rest is mathematics. Yes. So physics is circled. Yes. Okay. So what? Let's do. This is part A. This is answer part A. Answer A. And before we start part B, I want to make sure that there are no questions, or maybe there are questions. Okay, so let's do part B. And I think that in part B, they ask us to find corresponding distance, yes? Yeah, find corresponding. Yeah, and I have one last question today. How to do it? What's the strategy? Yes, and I don't know your name. What's your name?
John.
John. Yeah.
Plug your VO and theta max into the article.
One more time. Can you repeat? I think it was correct. Yes. Can you? Yeah. Can you repeat? So look, we have equations in 4 black boxes.
Okay.
Which one you would use to find the distance?
It's the dyt set equal to 0. Solve for yeah, it's the dyt.
No, because we already did it. Yeah. No. Anyway, but don't worry about it. Yeah. We want to find this distance. Look, this distance. Yeah. Oh yeah.
You solve for t-top using what we just got. You can use the x equation.
Yeah. This one. Yeah. Look, John. This is the because we are interested in this distance. Yes. Yeah. Awesome. Yeah. No worries. No worries. It's okay to make mistakes in dynamics during the discussion, you know? You should be champion of that after 15 weeks, yes? That's true, yeah? Nobody expects you to know everything before these 15 weeks, yes? Okay, so let's take this equation. Let's take this equation. And I think that you said that x at t top will be d exactly, yes? Okay. So our d will be equal to v0 cosine theta max. Yeah, because it's a corresponding distance, yes? Times t top. Okay, let's find t top on the side. Where was the expression for t top here? So let's just do like, as usual, let's do like 5 extra %. I don't like doing it, but let's do it. So what will be t top if we plug in values? It will be t top is 300 divided by 9.81 times sine of that what we just found, yes? Sine of 19.278. If you grab your calculators, you will obtain that t top is approximately, I believe, 10.096 seconds. T top. Okay, and now we know everything, and we can solve this problem. So d will be 300 times cosine 19 point something, 19.278 degrees times that what we just found, 10.096. For the last time today, grab your calculators and obtain that our distance is approximately, oh, that's a large number, 2,858, oh, 0.968. So almost 3 kilometers. So is it possible that such fireworks show will be that far away? No. I don't know. Okay, I don't know. Honestly, I don't know. But this is correct answer actually. Yeah, for that problem. Answer B. Okay, guys. It seems like it's the end. Yeah. Unless you have questions. Yeah. Yes, Sean. In this case, yes, because that parabola is symmetric. Yes. Yeah. In this case, it's true. Yeah. So the y0, in other words, the y0 will be obtained for 2t top. Yeah. Exactly. Yeah. Okay. Okay, guys. Thank you for today and enjoy your afternoon. Bye.